Hello students, in this video we'll discuss annuities that are payable more frequently than annually. Given P greater than 1, we consider IP the effective nominal rate of interest. So now we're doing nominal rates of interest. We let I be the corresponding effective annual rate. Let's consider the following payment stream. The payment stream we're going to consider is this one. Here's time 0, here's time n. Now what we're going to do is we're going to look at payments that happen every 1 over P. 1 over P, 2 over P, 3 over P, all the way down to n, which is n P over P, okay? And so at each of these increments over here, we're going to get a payment of 1 over P, 1 over P, 1 over P, 1 over P, 1 over P. So after the first P periods, we will have accumulated 1 total unit. So that's an important observation over here. So if we stop over here at 1, there was 1, for example, we get a 1 over P at 1. So how many of these things that we have? So from 1 over P, 2 over P, 3 over P, then I finally get to P over P, which is 1, on that interval over there, which is 1 year, we have what payments? We have 1 over P plus 1 over P plus 1 over P. A total of 1 payment occurs over 1 year. It just occurs at different intervals, okay? So that's the fundamental idea behind these annuities that occur P-thly, okay? So define, let a superscript P and I be the present value of this stream. Of payments. Okay, and so let's think about what this present value of the stream is going to be. Well, what will the present value be? So a superscript P and I is going to be 1 over P, new to the 1 over P, plus 1 over P, new to the 2 over P, all the way down to 1 over P, new to the NP over P. Okay? So what we have here is we have a geometric progression with a common factor of 1 over P. I'm going to pull that 1 over P out. So this is going to be, I'm going to pull out a 1 over P and then a new to the 1 over P out of everything. Then I'm left with 1 plus all the way down to new to the NP minus 1 over P. And so now by the geometric sum formula, what will this become? This is going to become 1 over P new to the 1 over P. And then we'll have what? Then we'll have 1 minus 1 more than this thing over here. So I'm going to increment 1 to that, which is P over P. So if we do so I'm thinking of my common ratio as this new to the 1 over P. So I'm going to have new to the 1 over P. So if we do that, we'll do 1 more, the N over P. So I'm going to have new over here. So my common ratio, my R, is going to be new to the 1 over P. So this is really like an R to the N P minus 1. Excellent. So I increment that by 1 more. I'm going to get a new, I'm going to get an R to the NP. So that's going to be new to the NP over P over 1 minus just new to the 1 over P, that common ratio. And the numerator is just going to simplify to what? The numerator is just going to simplify to new to the power n. So what we have over here is we're going to have and the p's are going to go in the denominator. So what we'll have over here is we're going to have that this is equal to 1 minus new to the n over 1 minus new to the n over what? Over P, and then 1 plus I to the 1 over P. And then this is multiplied by 1 minus new to the 1 over P. Okay, so let's simplify this a little bit further. This is going to be 1 minus new to the power n over P, and then 1 plus I to the power 1 over P. and then minus 1, because 1 plus I to the power p and nu to 1 over p, we're going to cancel out, so minus 1. And so now what is this expression in the denominator? This expression in the denominator, recall, that we know that there's a relationship. I know that 1 plus I is equal to 1 plus I to the power p over p to the power p. And so if I raise 1 plus I to the power 1 over p, this implies that I to the power p is p. 1 plus I to the power 1 over p minus 1. So our denominator is exactly just IP. So this is exactly just going to be equal to 1 minus nu to the n over I to the power p. Beautiful. So that's our formula for A and IP. So hence A n I superscript p is 1 minus nu to the power n over I to the power p. Now I can get some quick modifications of this with doing very little. I can run the same argument by shifting over all these payments by 1 unit to form an annuity due p-thly. And that formula will be the following. We can guess, and this is a good exercise for y'all. If I do annuity due paid p-thly, it'll be 1 minus nu to the n over d superscript p. And then, of course, as p goes to infinity, we get continuously paid annuities. So as t goes to infinity, we're able to conclude that a bar ni is going to be 1 minus nu to the n over delta. So I get all of these streams of payments over here. So I get this continuously paid annuity. Okay, I get the annuity immediate paid p-thly, and I get the annuity due paid p-thly. So those are good formulas to keep in mind. And they also immediately give us the results that as p goes to infinity, we get the continuously paid stream of payments. And so when someone says I have a continuous stream of payments, all that means that you look at payments at step 1 over p, and then you let p go to infinity as long as you're being paid 1 over p on that scale. So then there's the scaling, the length of the interval has to be identical to the payment that you get on that interval. Thank you very much.